Welcome viewers. Today we shall discuss with the problem of forecasting in the context of linear regression model. When we deal with any kind of empirical data analysis, after the estimation is being carried out, we have discussed about the inferential hypothesis testing. And after the testing is being done, it is imperative to look at the future dimension of the results. And this calls for future prediction or the forecasting. So the module 19 will be concerned about the forecasting techniques and with the help of the real examples, how can the future prediction be done based on the current values of observations. So this calls in for the concept of forecasting. What do we mean by the term forecasting in the context of the data analysis? Forecasting is basically a term associated with the time dimension. For example, if we want to deal with any estimation exercise up to the current period, how it will be effective for the future period, that will be decided on the forecasting tools. So forecasting is basically estimating about a time dimension in future and for a specific future dimension over a period of time. So that means time is a very important component or the dimension within the terminology of forecasting. Secondly, we have another important term in this regard is about prediction. So when we want to use the words prediction and forecasting, in most of the cases they're used interchangeably, but it should not be used in that regard. Because prediction is basically estimation of any event for future. So that can be any past, present or future, and so it is an estimation of an event which does not only look after the future dimension. So we need to say that all forecasts are predictions because definitely forecasting is about the future, but all predictions are not forecast. Because when we talk about the prediction, it may be about prediction about the current or prediction about the past or prediction about the future, but forecasting always of a future dimension inherent in it. This calls for the word forecast, which implies time series and future, but prediction does not. So when we discuss with the word of the forecasting, it has two important attributes. First, we have to deal with the time series data. For example, data on sales, data on profit, data on dividend, say up to the year 2022. And we want to forecast for 23, 24, 25 years. Or we can do for the time dimension. And accordingly, the prediction does not take care of all these things. So when we take care of the prediction, it only refers to the current or the past values. So thereby for forecasting, we need to understand about the tools that are used in the context of the two variable regression model. And the very common tool is ordinary least square or the regression analysis. Now we move on to some of the prerequisite qualifications necessary for forecasting. Because for forecasting a data, certain criteria need to be satisfied. Firstly, we go for what needs to be forecast. See, in order to go that, we need to understand the nature of the variable. If we want to forecast about the future sales, or future advertisement strategies, or future profit levels, or future food grain production, and in the field of economics, we also forecast about the future growth rates, then definitely the detail of the variable is to be stated. Then we have to understand the measurement of the variable, whether the variable is measured in monetary units or in expressed in percentage or in any other numbers. That is how units of analysis should come up. And then we have the time horizon, because the time may be up to the current time period and we want to forecast for the upcoming 5 years. So 5 years or 10 years or 6 years, this forecasting is very important. Secondly, we want to evaluate and analyze the appropriate data. So whenever we are left with a data, and data is basically the numbers, but that should carry a lot of information. So because of these, the data analysis needs to be done, exploratory data analysis needs to be done, and thereby we can suggest a proper tool for forecasting. That is what the data information is all about. Next, we have testing the forecasting model. So when we are testing the forecasting model, we need to understand what method we are applying. Are we minimizing the sum of errors between the actual and the predicted values? Or are we using any moving average method or any other method we are applying apart from the regression analysis? And thereby we also test the validity of the method, that's the accuracy of the result. And finally we go for generating the forecast. That means we get a series of observations which are the future predicted values of the observed variable. And finally we also measure the accuracy or the forecasting error at any point of time. So basically these are the 5 important criteria which are inherent when we go for the forecasting techniques. Now we go for the types of forecasting, because forecasting may be done in various ways. A researcher may deal with a qualitative data when the data is only about responses and the expressions are not in numbers but in characters, or the data is quantitative in nature. So whatever be the nature of the data, forecasting can be done. So in a qualitative study, generally it is done based on the guesses or the conjectures. That means we are conjecturing about this event to happen. So based on that, the forecasting is coming up. For example, we can forecast or we can just guess that there may be some rainfall in the coming months. So based on that, your agricultural output can be adjusted. But this is just an expectation. This is just a qualitative forecast. But quantitative forecasting can be done when we have the numbers, when you have the data set. For example, you have a data set for agricultural production. So we can find out what can be the estimated production in the next year or in the next 2 years. So that calls for quantitative forecasting. So whatever method we apply, we have to use the proper method. So in this particular module, we are going to deal with a quantitative methodology, and that calls for none other than the regression analysis, whereby we applied ordinary least square to explain how the mathematical modeling can be done for the forecasting analysis. So this basically leads to linear regression forecast. So when we go for a linear regression forecast, we actually follow a linear relationship between dependent and independent variable. So suppose x and y both are the current values, where y is dependent on x, a and b are the intercept and the slope coefficients. And as this is said, a and b are the population parameters. So we have some scatter plot where the actual plots are being done for the dependent variable y and x. So this is a scatter diagram where x and y are taken up in a coordinate structure. And we fit a line which is a linear, or it is actually upward rising or a straight line. Now we observe that there are some dots or plots which are near to this line and some are away from this line. So we can find out the difference between the actual value which are near to this plot or this fitted line and some are the predicted values. So this difference will be comprising the component of error. And in this OLS methodology, our objective is to minimize these errors. So what we observe here, the error is basically given up between the difference or the distance between the scatter plot which is near to the line and the scatter plot away from the line, and we want to minimize the error, and that is how we can do the actual value minus the predicted value, and that is how the error comes up. And that is what is explained in this particular diagram, particularly with regard to the linear regression forecast. So basically the linear regression forecast basically deals with a relationship which is between y and x and an error term, because this error term is an essential component of this regression analysis because it takes care of all the disturbances and the random terms. Then we go for solving for the unknown parameters which are derived from the population like a and b. So a is the intercept and b is the slope. So when we go for the slope of the line, then using our statistical formula, we can see that the slope is nothing but the covariance divided by the variance. So covariance shows the association between x and y divided by the respective variance of x and the variance of y in the denominator. So that is why we get the slope b. And after solving the equation, we get the expressions for intercept and the slope. So as we can observe, for the intercept we have y star minus bx star, where all the star values are the average values of y and x. And similarly, we develop the equation for the model, which is y equals to a plus bx. So that is how the fitted line is being structured. And in this fitted line, we have the equation as y and x, where a and b are the respective coefficients. One is intercept and the slope. So in this particular slide, we can see that by applying the method of the least squares, we can find out the expression of the slope coefficient, which is b, which is covariance by variance. And then we can go for the intercept, which is a, which is y star minus bx star, where x and y are the respective means, and we develop the equation of the fitted line. So now we see whether the actual value is away from the fitted line or near to the fitted line, and accordingly we minimize the sum of errors. So this boils down to a particular example of a linear regression problem. Now we go for the linear regression problem. Now in the context of this example related to the forecasting, here we observe that an automobile maker has been tracking the relationship between sales and advertising in rupees. So this is a study between the sales and the advertising, and definitely we can understand that the sales depends upon the advertising strategy that is adopted. Use linear regression to find out what sales might be if the company invested rupees 53,000 in advertising next year. So whenever the word next year is being mentioned in the problem, it's about the forecasting. Because what will be the estimated value of the sales if the targeted advertisement is rupees 53,000, and that is what the manager wants to look into. So this is absolutely based on the future time dimension because of the term next year, and also in the next year it's mentioned about 52,000 is invested in the advertising strategy. So now we go for the data that is provided. So in this particular data we have the data on y and x. Y refers to sales, which is in rupees, and X refers to advertising, which is in rupees. So these are the two variables where Y and X are related. Obviously, Y is a function of X because sales is a function of advertising. And now we need to find out the expressions for X, Y, because that is actually in the numerator of the expression of covariance, and respective X square and Y square we need to have. So accordingly, we have computed xy as a product of y and x, and then we have gone for x square, y square. Accordingly, the aggregation is being done as a total, and also the average values are needed, which are the mean values of y and mean values of x, or mean sales or mean advertising expenditures. So based on the slope coefficient formula, we have b equals to summation of xy minus n x bar y bar divided by summation of x bar minus n x bar square. So the workings are being shown, and accordingly by solution and by simplification we get the value of a and b respectively. So a is the intercept term, which comes up as 92.9, and putting that we can find out the slope of the function, which is 1.15x. So the estimated equation goes by y equals to 92.9 plus 1.15x. Now they have given us that in the next year the x is 53,000 because this is the estimated expenditure. Since the values are taken in 1000, we have put 53, and accordingly the estimated sales is calculated, which is the forecasted value of the sales or the forecasted value of the future sales. So in this particular model, it is interested to also get into the goodness of fit of this entire method, because we know that how the relationship becomes more and more strong between sales and advertisement expenditure. And for that, we need to apply the coefficient of correlation coefficient, which is by Pearson, and after putting the respective values, we get 0.964. That means 96.4% of the variation in sales can be explained by the variation in advertising expenditure, so it explains a majority proportion of it, and very less is unexplained. So this boils down to say that this model has a very, very good or a better goodness of fit. Now we move on to the issue of forecasting error. So when we talk about the forecasting error, we need to admit that in forecasting we're minimizing the sum of errors, so perfect forecasting is not possible, and that is the reality. So the first reality is this, that forecasts are never perfect. Next, we need to know how to rely on our chosen forecasting method. That is very important, what method we are adopting, whether that method is valid or not, that's very important. Secondly, we want to find out the degree of the forecast error. That means degree of the forecast error is E, which is actual minus forecasting. So if the deviation between actual and forecasting is very high, then definitely the error will be more. So the actual and the forecasting deviation should be as less as possible to make the forecasting technique to be accurate or to minimize the error. And there can be negative error, can be positive error, because actual value may be more than the forecasting error, AT greater than FT or AT less than FT, and accordingly ET will be coming up. So this boils down to different indicators of measuring forecasting accuracy. The first indicator is called mean absolute deviation. That means it is with regard to the sign, whether it is positive or negative. We can see that the mean absolute deviation is being done and we square it up to get rid of the minus signs. Next, we have to measure the bias, whether any bias is there in the forecasting. And this bias is captured by CFE or cumulative forecast error. So the first one is mean absolute deviation. The second one is cumulative forecast error. After that, we have the mean square error. That is actually one of the component of analysis of ANOVA or variance, where we find out mean square error is already being computed. And finally, we have to make a benchmark or a tracking signal. This tracking signal is very important, that whether the regression model is moving in the proper direction, this tracking signal should be done. So 4 important items are there. One is mean absolute deviation. Second one is cumulative forecast error. Third one is mean square error. And finally, we have to do the tracking signal, whether the error is minimized or whether the model is accurately forecasted or not. So this calls for certain expressions. So when I look at the mean absolute deviation, it is basically the sum total of actual observation minus the forecast divided by n. And we observe in the slide that actual minus forecast is within the modulus. There is a modulus associated with this range because it can be positive or negative. So to get rid of the negative terms, this modulus is taken up. Secondly, we have the cumulative forecast error, where the summation is taken and the difference is between actual and forecast, and that's done on a cumulative basis. After that, we have the mean square error, because it is basically squaring up the numerator. So CFE, cumulative forecast error, can be positive or negative, but mean square error is square of everything. And finally, we go for the signaling factor, that is basically the CFE divided by the mean absolute deviation, because CFE will come with the positive or negative value, and accordingly we shall understand whether the forecasting is done in the proper manner or not in the proper manner. Now we go for the practical problem related to the tracking and accuracy signal problem. It is basically comparing the 2 forecasting methods. So this is what the manager of the company finally does. The 2 forecasting methods are being done. Which method to be followed and which method is accurate, that needs to be decided. So a company is comparing the accuracy of 2 forecasting methods. Forecasts are done for the actual values for January through May. And accordingly, the company is using a traffic signal within plus minus 4 limits. So this signal is basically taking up the dimension of plus minus 4, whereby the forecasting error can be limited within minus 4 range to the plus 4 range. And finally, the comment is made regarding which method is considered to be one of the best methods. So this boils down to this table where we have method A and method B. So we have the particular months of January, February, March, April and May, and the actual sales are being given in the respective months. And based on that, the forecasting is being done. So for the method A, we observe that the tracking signal comes out to be positive in all the numbers. Thereby we have the tracking signals as 2 for January, whereas for method B it's 1. For February it's 3, for method B it is 1.5. For March it's again 3, and for method B it's 3. And April and May accordingly it is being done. We observe that the mean square error is much lesser in the method A and it is much more in the method B, because the mean square error should be less as possible as per the consistency and the credibility of the forecasting method. So we find out that 1.4 is for method A and 4.4 are for method B, and accordingly these two methods are being considered. So what we can see from this entire analysis of these methods is this, that first and foremost the amount and the type of the data that is to be considered for forecasting has to be clearly understood, because the data speaks a lot about the information, and whether the data is expressed in what units, that also needs to be understood, whether it is expressed in rupees or in monetary terms or expressed in terms of years or in metric tons. For example, agricultural production is expressed in metric tons, or any other variable, any other unit, that's need to be decided, and that is how the data has to be read out. Depending upon the data, we need to analyze the forecasting. That means it has a time dimension, so it talks about the future, and that is the departure from the concept of prediction. So prediction does not deal with any future dimension, but this deals with the future dimension. Secondly, we need to make the accuracy method very clear. For example, accuracy means more data. That means in any statistical exercise, if we increase the number of observations, then the possibility of committing error minimizes. Similarly here, accuracy also means that how the tracking signal can come up and how the mean square error can become less. Then we have the length of the forecast horizon. So different models are there, like we can maximum forecast for the 10 years, in a yearly data. For monthly data we can go for 3 months or maximum 6 months. So thereby the time frame needs to be decided when we go for forecasting any current observation. And finally, when we go for the lagging, for example, the forecasting model may have a variable which is dependent on these past values, and that is very evident in a real data. So when we deal with a stock price data or we deal with any kind of macroeconomic data, always the current value depends on the previous value. So based on that, the errors are also taken up. So depending on this type of model, the forecasting method has to be selected more accurately, because every disturbance is depending on the previous disturbances. So what we infer from this entire forecasting method is this, that firstly the data has a lot of information that needs to be generated properly. Then we have to think of a good way of forecasting tool, which method to apply. Generally method of least square is being applied. After that, we think to look about the future years, how long we can forecast, whether the forecasting can be done for 3 months in a monthly data minimum, or for years we can do the forecasting for 2 years or 5 years and maximum for 10 years. And accuracy of the forecasting tool also needs to be checked, and that calls for the tracking signal, which is depending upon the error. And overall, the mean square error should be less as possible to make the entire forecasting tool to be appropriate and accurate.